Okay, hello everybody. And today I'm here to talk about Silicon Valley and PKI from our perspective. We've got a short agenda for you, essentially a really short introduction on who we are. We want to just give you I don't know who's been to the Silicon Valley. Let me see a show of hands. Who's been to the Silicon Valley? All right, so a few of you, we'll just kind of give you a little bit of a background on what it is and where companies are located in the Silicon Valley and so forth. We'll give you just a brief, past, present, future, and where we see PKI in the Silicon Valley. And we're going to go through some specific customer use cases. We feel that they're a bit unique, different than the use cases that I've heard the last couple of days here. I think our use cases are a bit more enterprise-focused, internal-facing PKI infrastructure. And then we're going to have a demo, a use case demo, where we show some PKI in the automation in the cloud. And we'll have some questions at the end. So again, just a little bit about us. We're a consulting company, a professional services company. We've been in business for 15 years. We've been working with PrimeKey for over 5 years now. It's been a very successful relationship. We focus on the infrastructure, so not only PKI, but we focus on all the use cases surrounding PKI. PKI by itself, doesn't provide all the functionality required. It's always the integration. And I think Thomas alluded to that yesterday when he said hardcore PKI really is how it's applied and all of the integration. That's where a lot of the complexity comes in. So my name's Harry Haramis. I'm the CEO. I've got Thomas and Kong here. They're senior consultants, experts at PKI, experts at EJBCA, really. And collectively, we've got over 75 years of experience here, standing up. But yeah, I've been doing this for quite some time. Just one more slide on this. Again, so we focus on PKI and encryption, the network infrastructure, systems, and obviously everything's focused on cloud, really moving forward. And then we do quite a bit of compliance work because there's that layer that really needs to surround all the technology. Okay, so now Thomas is going to speak a bit on the Silicon Valley.
Yeah, can everyone hear me? Okay, great. So Silicon Valley, well, it used to be predominantly silicon, right? So a lot of semiconductors and data centers that use a lot of semiconductor stuff. And back then, there's more defense. There's NASA, and Stanford's close by with all the research there. So that Silicon Valley was smaller back then and more silicon, right? So, and then now, here's a map of it, and there's all kinds of companies out there, just like companies here. But we have a Silicon Valley originally was more in the South Bay, right? So you do have companies that are like there's Cisco and Apple started in Cupertino, as everyone knows, and companies like Brocade and Arista, a lot of semiconductor companies down in the South Bay, right? And then as we take the landscape to the present, there's even companies like Tesla, for example, that launched off from Fremont and Palo Alto. And then, the giants out there with the Google and the Facebook, LinkedIn's up in Mountain View and Palo Alto. Then moving up, we're in the Central Peninsula. We have the NetSuite, the Oracle, Qualys, a lot of startups start from here as well. A lot of VCs in the Palo Alto, San Mateo area, and all the way up to San Francisco, companies like Uber, Airbnb, the App Dynamics, all those companies, are all in around the Bay Area. So Silicon Valley now is a much, it covers the whole area, and the companies have changed over time. So, in terms of what do we see in the past, since we've been working with PrimeKey here, in the past we've seen more on-premise deployments. Right, we see companies, because there's no other options, we have to buy hardware, we have to set up VMs, we procure HSMs, whether SafeNet, Unomako, things like that. And then we install PKI software, right? And then when you want to roll your own software in PKI, it used to be you have some choices. You have Microsoft, you have OpenSSL, you have some other open source options out there. So we've seen companies, start with various types, and now we actually have a lot more options. We have EJBC Community, we have EJBC Enterprise as well. And back then, deployment times of 3 months or more because of procurement of hardware, installation of software, acquiring that knowledge, you can expect to see 3 months or more in the recent past. And the customers are more of the traditional enterprise companies and government, okay? So PKI in the Silicon Valley in the present, some common questions we've heard from as recent as the RSA conference in this year is, I want a PKI, but I don't have the knowledge or the staff to deploy it, right? Is this solution available in the cloud, right? And how do I secure data in the cloud with PKI? So these are some of the questions we get, and because of that, some of these companies, our potential customers, they come to us with a balanced demand for these options, right? We see more on-premise appliance fits because of the turnkey nature of it. We see more on-premise EJBC Enterprise in financial companies and even startups are using this today. And more companies are wanting to deploy it into the cloud. Okay, so we have an evolving customer landscape. Now we're seeing more companies in IoT, in payments, electrical vehicles, and a whole suite of cloud companies that are starting to use this in a very agile basis. Right? The common denominator is that companies know they need to secure devices, data, as well as scale. And oftentimes PKI is a solution, and oftentimes PrimeKey becomes part of that conversation. All right, so what do we see about PKI in the future? Really, it's in the areas of agility, security, and some capabilities, right? We're seeing more DevOps automation and cloud focus where we live in today. And companies want to deploy these PKI very quickly. Starting to see more questions about containerization of EJBCA, infrastructure as code, right? Using tools such as Terraform, and Kong will talk about this and give a little demo, and where we can secure the PKI right out of the box and push a button. The capabilities are more around the IoT use cases, the integration. We cover things like Mobile Iron and AirWatch. All these are components that can hook into PKI. And the goal is really about seamless and secure provisioning certificates. And companies are asking for more secure options for key storage. We have Cloud HSM, so it's integrating that with the PKI. And then they will also want to access the PKI through more, not just the web UI, but REST and microservices as well. So this is a glimpse of what we're starting to see in the near future. And oftentimes when we have customers, customers ask us about what's a good fit. If on-premise hardware key management is important, then obviously the on-premise options of the appliance, or you procure your own HSM and you deploy an on-premise EJBC and Enterprise, right? If cloud hardware key management is an option, such as AWS Cloud HSM, then the Cloud EJBCA Enterprise deployment is what we typically recommend. And as far as turnkey and full stack support from PrimeKey, the appliance is the one form factor that fits this mode. And sometimes customers have asked us to deploy in as fast as 1 week. In those cases, we recommend the appliance or the cloud option. And if they have a larger, more complicated environment and they have the time frame for it, 4 weeks or more, we can even go with EJBC Enterprise or any of those appliance options as well. So this is PKI as we see it today.
Okay, so next I want to cover a couple of use cases. So we have Cisco was here the last Tech Days speaking. They couldn't make it this time, but they actually endorsed me speaking about this solution, and we played a large role in this project. And they actually provided some of the slides that I'm going to present here. And this was a very interesting use case in that it wasn't just leveraging EJBCA as a PKI infrastructure, but it was actually embedding EJBCA into their management platform. So I'm going to talk a bit about software-defined networks and how PKI plays a big role. So it's a fact that rapid deployment in the enterprise is key. You used to have new applications would take weeks or months in some cases to provision. I think there's been a lot of momentum over the last few years. Systems, storage, and some of these other components can be deployed in minutes now. But it still seems like the network and the wide area network always lags behind. And this is really a problem that needs to be solved. Cisco sees that most of the money is spent on operations, not so much the capital expenditures. And they see most of the delays coming from the network. So now you see budgets being allocated towards fixing this problem. Networks are not getting simpler. They're getting more complex. They're needing to support all of these additional applications, IoT and mobility, and it's just getting more and more complicated. The traffic's increasing, so the scale, it's just the scale is out of control. So really, we need to figure out how to do a lot more with a lot less. So Cisco's solution for really the wide area network was a SDN controller called the APIC-EM. The APIC-EM is something that you run in your infrastructure. If you're a large organization with 3,000 branches or something of that nature, you have a very large wide area network. It's very expensive. So really, Cisco sees a need to provide a solution in this area. So typically, these organizations have transferred their wide area network from expensive MPLS type of circuits. They're trying to use less expensive internet circuits and cellular backup, for example. The issues with that are interactive traffic. You really can't guarantee that type of, you can't do QoS on the internet, for example, very easily. So companies are trying to figure out how to leverage all of these and use the right transports for the right type of traffic. Historically, this wasn't very flexible. I mean, routing is based on IP addresses. There's really not a lot you can do at the application level. So what they've provided is a solution to allow for intelligent routing from an application perspective. So you really can have the transports be completely invisible to the infrastructure or to the network manager, I should say. You can have the controller in this case steer traffic across the appropriate circuits, so you can get less expensive MPLS circuits and really only use that for your voice traffic, for example, or your any type of interactive traffic, and steer all your bulk traffic, batch traffic, and so forth over the less expensive internet connections. And of course, all this needs to be done in a secure fashion. And really, how do you do that in a secure fashion? Really, the answer is PKI. So PKI is leveraged to really secure all the connections between all of these network devices. So not only encryption, but also authentication, obviously. So the APIC-EM really provides quite a few functions. Again, PKI really being at the center of all this from a security perspective. So again, really what in the past, we were able to do some of this without PKI, but really that doesn't scale, it doesn't work. IPs are dynamic. Your network devices are popping up on different IPs all the time. You really can't do things based on source IP. Shared secrets used to be used. I mean, obviously that doesn't work. It doesn't work because somebody can basically get a hold of a network device and bring it up somewhere else and get on the network. So that's not the answer. PKI and certificates really are the chosen solution here. So here's one of the benefits of their solution. You can essentially, a company can ship a completely stock network device to one of their locations. They can choose to bootstrap it with a USB fob or some other way to get a bootstrap configuration file on this device. Power it on, the device essentially just calls home. If new firmware needs to be loaded, it's done. PKI takes place, so a certificate's provisioned to that device dynamically, and now that device is joined to the network. So Cisco obviously has many years of PKI involvement. They I believe invented SCEP. They've really contributed a lot to PKI. So internally, I think they told us they had a dozen internal PKI implementations. So a Cisco router can be a CA. They've got multiple CA implementations internally. But when they went to solve this problem here and find a PKI solution for this SDN controller, they chose to look at EJBCA. So they actually started with the EJBCA community. The developers quickly proved that it plugged right into their system and provided 95% of the functionality, and instantly contacted PrimeKey and asked for some support. And so the engagement kicked off. At that point, PrimeKey identified the remaining 5% functionality that was required and I'll talk about a little bit of that. And C2 being located in the U.S. and having a long history with Cisco and other networking companies, we were perfect to be brought in and be the consultants in this engagement. So some of the enhancements that were introduced with this engagement, I think Thomas actually highlighted some of these enhancements yesterday. And these were enhancements that were, again, brought into this engagement and actually added to EJBCA Enterprise. So the ability, some SCEP extensions for client certificate renewal, for CA certificate rollover, and some WSAPI extensions to create a new CA, for example, and monitor certificates for expiration. So now, putting it all together, once EJBCA was completely integrated into this management solution, which, by the way, Cisco gives away for free, and EJBCA is embedded in every version that's loaded. So the slide obviously is not meant to be read. I think the point we're trying to make here is there are a lot of PKI-related implementation parameters and configuration that needs to be done. So if you were an administrator that you wanted to roll this out on your own and not use an integrated solution, these are the types of questions that you need to ask and configure and knobs you need to turn essentially. And this is really all under the hood. Again, more complexity under the hood. There's really a lot that happens here to make all this work. And it's essentially completely baked and seamless. PKI and certificate lifecycle management is completely built into the solution. So basically it's all automatic. The administrator really does nothing. There's automatic renewal. There's essentially, it's all under the hood. And finally, here's another example of revocation. It's as simple as the administrator removing a site, and all of this happens in the background where the certificate's revoked and all this other functionality. So it's really quite an experience to be part of this engagement. And I think if you ask Cisco, this is a complete success. Very happy with the way EJBCA just plugged in, the way PrimeKey supported Cisco throughout this engagement. And we're still actually involved in providing Tier 3 support to Cisco's TAC when there's an issue that a customer has, and it ends up going through the tree and ends up being a PKI issue. We're still supporting Cisco's TAC. So that's the Cisco use case. Here's one more use case I want to discuss, and this is more of a classic enterprise use case supporting internal customer end users. For those of you that don't know Gap, they're a pretty large clothing retailer. They've got quite a few brands like Banana Republic, Old Navy, and some others. They've actually got over 3,000 stores globally. So the goals of this project were to implement 802.1x certificate authentication for strong wireless authentication. Previously to that, they had basically some pre-shared secrets or Active Directory type wireless authentication, and they knew that wasn't the right solution for them. The goal of the project was to start with their Silicon Valley sites, very tech-friendly audience there, and then ultimately to deploy this to all of their 3,700 stores globally, including their point-of-sale systems and all of their use cases for wireless authentication. So we had quite a few clients to provision these certificates to. We use tools such as Windows Auto Enrollment, and we actually used PrimeKey's Windows Auto Enrollment component to plug into their existing Active Directory and essentially provision all the certificates to all their clients through this mechanism. We used a product called JAMF Casper. It was an existing OSX desktop management enterprise desktop management solution to provision the certs to all their OSX machines globally. And then they had an MDM solution, and we used that to issue certificates to their mobile devices, AirWatch in this case. Some of the challenges that we faced and really overcame through this project. It was a multi-vendor situation, so they did use Cisco WLC and traditional Cisco Wireless and Cisco Meraki, but really they're two completely separate products. Meraki was just an acquisition. So there was quite a few integration issues with multi-vendor. They had a centralized IAM portal that was quite sophisticated, and we used WSAPI and helped their developers internally really integrate into the PrimeKey solution. They had a Juniper NAC solution, and that was quite complex and quite involved to have that integrate and all function together. And then they had issues with Windows certificates being exportable from machines where users had administrator privileges. So all of these were issues that we faced and solved throughout this project. All right, So with that, we're going to talk about one more use case, and Kong will cover that.
Sure. All right, so another case study that I'll be talking about is a payment device customer that we have. So why did we use EJBCA for this customer? Basically, this customer required a PKI solution that was able to be deployed in the cloud, in Amazon Web Services. It also needed to be able to use a cloud service HSM. This company also wanted to use very flexible APIs. And the purpose of the CA was primarily for signing application packages. So the decision that was made was that EJBCA was the best solution to be used that met all the requirements. And we were able to implement this solution within 2 weeks. Here's a high-level diagram of all the components that we use in AWS. So the main things to highlight here are that there are two VPCs, and there are 3 EC2 instances, one for EJBCA, one for OCSP, and a separate one for controlling the HSM and managing the keys. The cloud HSM itself is in a separate VPC. And the database backend that we use for both EJBCA and OCSP, we're using Amazon's RDS solution. And also for DNS, we use Route 53. And for high availability, we're using elastic load balancing and auto-scaling group. Auto-scaling group basically for always maintaining at least one instance of EJBCA alive in case for whatever reason it shuts down or it crashes. Next thing I'm going to talk about is the automation that we've been starting to do, and more customers are starting to want more automation, as Thomas was speaking to earlier. Some of the tools that we used, one is the HashiCorp Terraform, and also the second one is Chef. Most of you are probably more familiar with Chef, but Terraform is a tool that allows us to automate building infrastructure as code. So what this will do in this demo that you'll see is it will help us create the EC2 instances. It also configure the security groups for your instances, as well as update your Route 53 DNS entries, and also help you do the automated deployment of EJBCA. What Chef will do in this case is it will update the operating system configuration. In this case, it will be Linux. It will do the server hardening, and it will also update the users and groups in the system, and also secure your SSH server. Do we need to do screen sharing?
It's live demo. It's not PowerPoint.
Well, not quite live demo. It's a recording that we did, because you know how it goes when you do live demos.
We're positive it would have worked, but
It doesn't always work.
it's always that 1%.
So I'll be playing this video here. This video is about 3 minutes long, but it's mainly fast forwarded. The actual process takes about 16 to 17 minutes. So some sections are a bit fast forwarded. So the only thing I'm going to actually do in this video here is run a single command, and everything is automated. So basically what will happen is I'm going to play this now, and we need to apply the Terraform configuration. So just run a single command. It's a Terraform shell script, Terraform apply. And the first thing it's going to do is it checks to see if you have any existing configurations, and if there are, then it will remove them. So that's what you're seeing right now. This here takes about a minute or so. And once it does all the cleanup, this is Terraform code that you manage and you define what your EC2 instances resources will be, and so it displays it on the screen for you. And what you're seeing right now is that it's actually creating the EC2 instance in AWS, and so it's being provisioned. Once the once the EC2 instance has been provisioned, then we kick off the EJBCA install. So this is heavily fast-forwarded because it does take quite some time to install EJBCA from source. So that's what it's doing right now, deploying Wildfly and doing the EJBCA configuration and installation on top of Wildfly 9. And once EJBCA is done installing, we restart the service. So now EJBCA itself is actually in a working state. And we kick off the Chef client to do the remaining operating system updates, such as adding the separate users that we deem are appropriate to access the system. And also we secure the SSH server. And lastly, what you'll see here is adding the DNS entry into Route 53 so that you can access this server through a DNS hostname. Okay, so now the server has been provisioned, everything has been configured, and now we just need to do the standard process of getting your superadmin certificate so that you can import it into your Firefox browser, and you're going to be able to log into the administration web using that. So it's just a simple SCP command to copy the file right here. And once you have the superadmin certificate, you just simply have to go through the motions of importing into your browser. That's what you're seeing right here. And you enter your password. And once you have that done, your browser can now access the site. Right now I'm just punching in the host name. And it's going to prompt because it doesn't trust your CA yet, so you'll see that standard prompt. You select your superadmin certificate, and what we're showing here is that this is the brand new EJBCA instance that has just been spun up within about 16 minutes, all on Amazon Web Services. Okay, and that concludes our presentation.
Earlier in the conversation, you mentioned IoT. What sorts of requests are you seeing from customers in IoT, and are you seeing folks deploy beyond just POCs?
Yeah, so there are a couple of IoT companies that we're at various stages of working with. Some have IoT networks deployed using a homegrown PKI solution, for example. And one company, for example, has smart meters. So they have networks of hundreds of thousands of devices. So that's a classic IoT solution. Another is an electric car manufacturer. I think a car is a thing, I guess, right? Other devices are, for example, access points. So we have a customer that uses EJBCA to issue a certificate to every access point that's manufactured and shipped to a customer. So we're seeing the use cases come up more and more now.
Thank you.
Sure.
Very good presentation. I guess, two questions for you. So when your customers come to you, do they come saying, hey, I need a PKI solution, or do they come to you with a problem, and then you say, hey, I can use PKI to solve your problem? And then secondly, once you go down that road and say, hey, we have a solution here with PKI, do your customers typically provide you with the security requirements or the certification requirements and how you deploy things, or the expectations? Do you need to use like an HSM, or are P12 files acceptable? Do they have any, you need to follow FIPS or anything, other RFCs or anything like that? Or is it more that they just basically come to you, hey, I have a problem, can you please help me solve it, and you guys kind of drive it that way?
I think the answer is yes. It's all over the map. So the first use case I showed was Cisco. They were very specific. They knew exactly what they needed. Not only did they know they need PKI, but they knew they needed these exact extensions to EJBCA that were not there. So they're very advanced, right? They're a software development company, I guess you can call it now, and so that was a very well-defined scenario where there was no question that we were going to use PKI. The second use case I discussed was Gap, and no, I mean they basically knew they needed stronger authentication for their wireless, and so they knew that certificates were one solution, but there's also other two-factor authentication. Really, their goal was we need multi-factor authentication for our wireless. It could be username, password, and some type of one-time password or voice. I mean, who knows what, right? Certificates are one-factor authentication, and for a wireless deployment, it makes the most sense. It doesn't require another user interaction beyond the initial provisioning process. So we made the recommendation that certificates were the solution, and it was, nobody objected to that at that customer. And then we proposed EJBCA as the right solution because the idea was that wireless was the first use case there, but they have plans for other use cases on their internal infrastructure that are perfect for certificates and for PKI. And so at that point, they needed obviously a lot of help with the. I think you mentioned the policies and so forth. They need a lot of help there, and we did all that for them. All right. Thank you, everybody.
Thank you.